Hello, my name is Farhaan Nazirkhan and I'm joined by Sarwin Rajiah, and today we'll be presenting our research project focused on heart attack prediction using machine learning models. In this project, we explored various machine learning techniques to predict heart attacks using a comprehensive dataset of 1,888 records and 14 attributes. The attributes included key indicators such as age, cholesterol, ECG results, and more, which are crucial in determining heart attack risks. We implemented two machine learning models, a decision tree classifier, and a multi-layer perceptron, which is a type of neural network. Both models were rigorously evaluated and tuned for optimal performance. Without further ado, let's dive into the implementation. Starting with the curating dataset section, in this cell, the Kaggle dependency is installed. Over here, this cell of code downloads 4 out of the 5 datasets from Kaggle using the Kaggle API. Over here, the last dataset is downloaded from Figshare. And here, this set of code unzips and renames the CSV dataset to hot dataset 1, 2, 3, 4, and 5. Moving to the preprocessing section, over here, the following cells loads the unzipped dataset into memory and renames the columns with standardization. As you can see, for all the 5 datasets. Now over here, this cell of code merges all the dataset into one CSV file. And here, after merging the 5 datasets into one, the CSV dataset is cleaned by removing all the rows that contains missing data. As you can see. Now we are going to look at the decision tree classifier. Over here, we are installing the dependencies that are required. Here we are loading the clean merged dataset. Here is the code for model training. As you can see, we have pruned the tree, the model, to prevent overfitting using a value of 5 for the max depth. And here is the code for model evaluation. So over here in this cell, we have done multiple runs to find the best random state, and the one proven to be is 8412 with an accuracy of 0.9232. Over here, we have trained the model using the best random state and evaluated it using this code. Here is the performance matrix in text. As you can see, an accuracy of 0.9233 and F1 score of 0.9233 again, which means the model is well balanced. Now we are going to look at the confusion matrix accuracy, precision, recall, and F1 score in terms of graphs, as you can see here. And over here, the confusion matrix states that 166 cases of heart attacks have been correctly predicted out of 183. Here is the decision tree visualized. Here is the learning curve. Now we are going to look at the multi-layer perceptron classifier. Over here, as you can see, we are installing the dependencies required. Here we are loading the cleaned merged dataset. Here is the function for model training and model evaluation. Here we are doing a hyperparameter fine-tuning. So we have chosen the best activation function, which is the one with the highest accuracy, as you can see, logistic. For the best batch size is 200. The best learning rate is constant. The best number of epoch is 50. And the best hidden layer configuration is 2x50. Over here is the best hyperparameter report. And over here is the model training with the best hyperparameter. So as you can see here, we have chosen a value of 1000 for the epoch. We did this since with the value of 50, the optimizer was not converging. So here, as you can see, we have evaluated the model. Here is the model evaluation. So these are the metrics. We have got an accuracy of 92.33%. Here is the confusion matrix, accuracy, precision, recall, and F1 score, as you can see below. Here is the learning curve. And lastly, we have done a feature importance analysis. To conclude, in this study, we evaluated two machine learning models, decision tree and MLP, to predict heart attack risk using a dataset of 1,888 records and 14 features. The decision tree and MLP classifier both achieve an accuracy of 92.33%, highlighting the importance of hyperparameter tuning and data preprocessing. We also address gaps found in previous studies by merging multiple public datasets and incorporating critical features as mentioned in our report. For future work, we will use feature importance analysis to further optimize the models. Therefore, this study demonstrates the potential of machine learning for early heart attack detection. Thank you for watching. We hope you enjoyed our presentation.